This lesson is on empirical to molecular formulas, and specifically we'll be doing calculations to figure out empirical and molecular formulas. So let's take an example of a compound. So the compound dinitrogen tetroxide has a molecular formula of N2O4. The representative particle is the molecule. Our empirical formula, the lowest whole number ratio of the atoms, then is just NO2. And then we talked about this N factor. What we need to multiply the subscripts by to go from empirical to molecular, or what we divide the subscripts by to go from molecular to empirical. So we can see that our N factor is a 2. Okay, so I'd like to take a look at the formula masses for the empirical formula and the molecular formula. So to get our formula mass, we have 1 nitrogen and we have 2 oxygens. From the periodic table, nitrogen has a formula mass of 14.01 and oxygen has a formula mass of 16.00. So we'll add them up. 14.01 plus 2 times 16, and we get 46.01. Okay, now we're going to do the same thing with N2O4. So we have 2 nitrogens and we have 4 oxygens, 14.01 and 16.00. So we do the math and we get 92.02. And remember that if we have 1 molecule of dinitrogen tetroxide, it has a formula mass of 92.02 atomic mass units. If we have a mole of N2O4, then we have 92.02 grams in 1 mole. So if we look at our empirical formula mass, and the molecular formula mass, to get from here to here, we just multiply by 2. 46.01 times 2 equals 92.02. So our formula mass of the molecular formula divided by the formula mass of the empirical formula gives us that N factor. So we can write a formula for that. Our N is equal to the formula mass of the compound divided by the formula mass of its empirical formula. And we can also put that in terms of molar mass. We can say that N equals the molar mass of the compound. Oops, yeah, that's right. Divided by the molar mass of the empirical formula. And these are the exact same numbers. The units cancel out. So AMUs over AMUs cancel out, or grams per mole over grams per mole cancels out. So these will give you that same N factor. All right, so we can use this to solve problems, such as this. A compound has a formula mass of 221 AMU and an empirical formula of C3H5N. What is the molecular formula? Okay, so we're going to use that formula that we just developed for N, but first we'll get the formula mass of the empirical formula. So carbon, we have 3 of those. Hydrogen, we have 5. Nitrogen, we have 1. Get our values from the periodic table. 12.01, 1.008, and nitrogen is 14.01. Let's add them up, see what we get. 3 times 12.01 plus 5 times 1.008 plus 14.01 equals, so we get 55.08. All right, now we're going to use that formula. So our N factor equals the formula mass of the compound that were given in the problem, so 221 atomic mass units, over the empirical formula molar mass, or formula mass, which we just calculated, 55.08. Okay, let's do that calculation. 221 divided by 55.08 equals. All right, so my calculator is showing me 4.0123, lots of other digits. Now, this n is going to be a whole number. So we round to our whole number as long as we're really close. This was 3.6. That would mean you did something wrong somewhere, but 4.0123, or we're going to call that a 4. So now we have our n factor, and we know our empirical formula. So to get our molecular formula, so our empirical is C3H5N, and we'll multiply all those subscripts by a 4, so we get C12H20N4 for our molecular compound, just like that. Okay, let's do another one. Okay, here we have a compound as an empirical formula of P2O5, and the molar mass of the compound is 280 grams per mole. What is the molecular formula? So we do the same process. Now we're just given grams per mole, but it really doesn't matter if we have grams per mole or atomic mass units. Okay, let's get the molar mass of our empirical formula. So we have 2 phosphorus, 5 oxygens. Look on our periodic table. So phosphorus 30.97 and oxygen 16.00. Let's add them up. 2 times 30.97 plus 5 times 16 equals, and we get 141.94. Great. Now we can calculate our n value. So n equals the molar mass of the compound, 280, divided by the molar mass of the empirical formula, 141.94. Let's see what our calculator tells us. 280 divided by 141.94 equals. All right, so now we have a 1.97, lots of digits. That rounds up to a 2. It's very, very close to 2, so we're good with that. Because a lot of times this is experimental data, so that is fine. Okay, so now we take our P2O5 empirical formula, multiply it by the n factor, and we get P4O10. Awesome. Okay, now we're going to look at something a little more complicated, but not too bad. We can do it. We're going to learn how to find the molecular formula of a compound given the percent composition data and the formula mass or molar mass of the compound. So now we're going to have to figure out the empirical formula to be able to get to the molecular formula. So we're going to go back to that poem that we wrote for empirical formula, and we're going to add to it. All right, so we start out percent to mass. Mass to mole. Divide by small times 2 whole. So we can go all the way from percent composition to our empirical formula. Now we're going to add on. So our next line is calculate n, and then multiply it by the subscripts. The end. Okay, so we're just going to follow our poem for our next example. Okay, so we have a compound that has a formula mass of 180 atomic mass units and is 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. What is the molecular formula? All right, now I will say that there is another way to do this, and some students just figure it out on their own, but I'm going to do it following the poem. If you figure out the other way, that's fine, but we're going to do it this way. Okay, so we're going to do it just like we did empirical formula. So 40% carbon with a 100 gram sample means we have 40.0 grams of carbon, 6.7% of 100, 6.7 grams of hydrogen, and 53.3% of oxygen means we have 53.3 grams of oxygen in a 100 gram sample. So now our poem, mass to mole. So for each of these, 1 mole over our atomic mass from the periodic table, and times 1 mole of hydrogen is 1.008 grams of hydrogen, times 1 mole of oxygen, 16.00 grams of oxygen. Okay, so let's calculate those. 40 divided by 12.01 equals, so we're getting 3.33 moles of carbon. 6.7 divided by 1.008 equals, so here we have 6.65 moles of hydrogen. And we don't have to worry about sig figs here, just more sig figs is better than less at this stage of the game. Later on we round, but not here. 53.3 divided by 16 equals, and we get 3.33 moles of oxygen. All right, so now we have our ratio of carbon to hydrogen to oxygen, 3.33 to 6.65 to 3.33. Okay, the next line in our poem, divide by small. That's 3.33. Okay, so that's a 1, and this is a 1, and that's going to be near 2. Let's see exactly what the calculator says. We are, all right, so it says 1.99699. That's a 2. It's really close to 2. All right, so that gives us our empirical formula. CH2O. So now we want to get to the molecular formula. Now we need to calculate N. So to calculate N, we're going to need the formula mass of our empirical formula. So I'll do that up here. So carbon we have 1, hydrogen we have 2, oxygen we have 1. So carbon is 12.01, hydrogen is 1.008, and oxygen is 16.00. Let's calculate that out. Let's see what we get. 12.01 plus 2 times 1.008 plus 16 equals. Now we get 30.03 if we take it to 2 decimal places. Okay, now we'll calculate our N factor. So N equals the formula mass of the compound, and we're given that in the problem right here. So N equals 180 divided by the formula mass of the empirical formula, which we just calculated, 30.03. Okay, you can probably see what that is, but 180 divided by 30.03 equals. So we get 5.994. That is a 6. So now we go to our empirical formula, our CH2O, and we multiply all of our subscripts by 6. So we get C6H12O. And that is glucose. There you go. Okay, that's it. So just follow the poem and you'll be good.